talk about some of the specific hardware that you'll find in your home. And let's start off with some pretty common items. These are items which exist behind the walls of your house. You've got a couple things here. This is called a junction box. And the junction box is going to be behind the walls in your house. It's made usually from galvanized steel. And junction boxes are typically connected to each other with metal tubing. That metal tubing is called conduit. It's also galvanized steel. And what you do with the junction box, first of all, is a junction box, its function is to provide a mechanically secure location to attach outlets and switches. Okay, mechanically secure. That means you can have these switches and outlets solidly attached to something. Okay, so that's the first purpose of a junction box. If you look at the cover plate here, you get the idea. You could have an outlet in there, you could have a switch, and this cover plate goes on top of the junction box, and it's a mechanically secure enclosure. The second thing that a junction box will do, and the cover plate, is they provide an electrically grounded enclosure that can protect people in the event of an electrical problem. So the idea is that this stuff is made out of metal, and that metal is grounded in the basement of your house so that if you have a short circuit inside someplace, the electricity is going to go through the metal. It's not going to go through a person who happens to be touching it, because electricity always follows the easiest route to ground, and so it's going to follow the outside of this. Okay, another bit of hardware that I'm sure that you're familiar with is called an outlet. This is called a duplex outlet. Duplex because there are actually two outlets built into one unit. And if you ever look at a duplex outlet, I think you probably would recognize this pattern. There's a wide slot, a narrow slot, and a hole. The wide slot is the common voltage source, or I should say it's just the common connection. The narrow slot is the hot. Now that's actually where the voltage source is putting out the voltage. So they make it a smaller slot because it's harder for little kids to stick things in there, because this is the one that would get you into trouble. The hot is the one that goes to 110 volts. The common, if you remember from an earlier lesson, common actually is at 0 volts. So there really isn't any danger per se to putting something into the common. Don't go and do that. But the hot is the one that you have to really be careful of. And that third prong down here, the round one, is the ground plug. And we've already talked about the idea that a lot of appliances have that third or extra wire to provide safety for users so that they don't get electrocuted. This is a common item in houses. It's called an on-off switch. It basically works like the switch that we used in our lab last week. You can either open the switch as picture, or by flipping that little lever, you can close the switch. When you put a switch into a circuit, you typically connect the hot wire to the top part of the switch. Electricity flows through, and then when the electricity comes out, it goes to the device coming out through the bottom part of the switch. And that's a standard way of connecting switches. So the hot is connected here. This is always hot. And then down here, this can be hot when the switch is closed. When the switch is open, it's not really getting any voltage at all. Okay, let's take a look at a light bulb socket. It's very interesting. You can screw the light bulb in here. We've already kind of talked about these a little bit in class. If you were to look at a cross section, you would see that a light bulb socket consists of several conductors. The black conductor here, that's the outside part of the light bulb. That's the threaded part, okay? And that's the common connection. So the idea is that outside threaded part is always going to be neutral. It's always going to be 0 volts. So if your finger slips into the outlet when you're putting a light bulb in and you touch that, you're not going to get electrocuted because it's always at 0 volts. Now, the part that's way down deep inside, you can't hardly see it in this picture, but that way down inside there, that's actually the hot connection. And that would come from the switch. So when somebody turns the switch on, the 110 volts is delivered to that small connector right there. And that touches the bottom of the light bulb, and of course electricity flows through the light bulb and it comes back out through the side, and you've got a complete circuit. Okay? So what's really important is that you know that this piece in here is always going to be the hot from the switch, and the part on the outside is always going to be the common. Okay, this page has a lot of notes on it, and you might want to pause the video after I'm done talking so you could copy some things down. Just a couple things here about that you need to know. One of them is what's called wire gauge. Wire gauge tells you about how thick the wire is. Okay, and generally speaking, thicker wire can carry larger currents, and we should know that. Now, what's a little bit confusing about wire gauge is the way that it goes is that the smaller the gauge number, the thicker the wire. Okay, it's kind of the opposite of what you might expect. But the smaller the gauge, the thicker the wire, therefore the more current it can handle. So here are my examples here. 14 gauge wire is wire that can handle up to 15 amps of current. Okay, we're going to use 14 gauge wire in the class. Okay, it's not that thick. It's pretty easy to bend with your hands, and it's pretty easy to do stuff with it. Your house may have a lot of 14 gauge wire in it. Okay, 12 gauge wire is thicker wire, and it can handle more currents. It can handle up to 20 amps. So it's a little bit weird because you might think, well, going from 14 to 12, that's getting smaller. Actually, the wire is getting thicker, and you know, that's just the way that people have agreed to set up this system for naming wire gauge. Okay, so if you're going to use 14 gauge wire in your house, you'd better make sure that the 14 gauge wire is connected to a circuit breaker that will shut off the current at 15 amps. Because if you go above 15 amps, you're going to have problems. So you would never connect a 14 gauge wire to a 20 amp circuit breaker, because that could be a dangerous situation. A couple things here about the colors of wires. There are some standards, and electricians will generally use green wire. That is wire that has green insulation on it to represent ground. And that's kind of easy to remember because G and G go together, so green is ground. Black wires, or wires with black insulation, are generally hot wires, so you've got to be especially careful with those. That's your 110 volts. White wires are the common or the neutral wires. These are the ones that are at 0 volts. These are the wires that provide a return path for the electricity. And colored wires like blue or red, or sometimes striped wires, are basically wires that are coming from a switch. And you have to be careful with those because they're hot when the switch is closed. And you never should assume that a switch is open or closed. So you kind of treat these like they're hot wires. So any wire that comes from a switch is going to be kind of a different color like this, blue or red, say. Okay, and one last thing here about wires. This is just kind of a rule of thumb that when you actually go and wire a junction box, which you're going to be doing in a day or two, give yourself lots of extra wire, okay? And I mean like 6 to 8 inches. And so don't cut your wires so short that you can't pull the attached devices out and look at them. Sometimes people think they're going to save wire and they're going to make the wires as short as possible, but that makes it really difficult to actually take anything out and look at it. So you'll be reminded of this in class, but you know, it's just a heads up. When you're wiring something, always give yourself extra wire so that you can, you know, pull things out. That wire is really compressible. You can always coil it up and shove it into the box, and there's no harm done. So it's much better to have the extra wire. Okay, so I think that concludes kind of our online component here. Actually, there's one more thing, but let's just go through next steps. So the next step here is, if you haven't done this already, please draw a circuit sketch on page 5 of your packet. All right, you can read the description of what you're supposed to do, the type of circuit that you need, and I'd like you to make a sketch on page 5 and use the symbols that it shows. Then go ahead and test your design in FET. It should only take a minute or two to input your design. If it works, great. And if it doesn't work, try it in FET and see what does work. And I want you to modify your circuit until it works. And then go ahead and draw and label the wires in the circuit diagram, which is on page 6 of your packet. And you're going to need to now use what you learned in this video. So give it your best shot and we'll talk about that on Wednesday when you come back to class. Then you want to go ahead and watch the video Making Connections. That's a short one. It just shows you how to make pigtails and terminal connections. It's a little bit of hands-on advice that will help you out. So make sure that you've watched that, and I think there's some space in your packet to take a few more notes on that. Okay, so one more video and then you're all done. And finally, when you're done, you can take the online quiz. Feel free to use your notes packet, but make sure that you've taken that quiz before midnight tomorrow, Tuesday, because that's going to be your ticket for class on Wednesday. Okay? All right, so have fun, and we'll see you soon.